I've defined this function called make balance. And we want to basically make a balance, or a model of a bank account. So, well, the first thing we know it's going to have to be a higher order function because we've seen the example. So I'm going to define that higher order function as withdraw, so that we're just very clear. So we want to withdraw a particular amount. And then we also know that on the outer function is going to return this withdraw function. So that's the basic idea of this function, the essentials. Now, when we first make a deposit, what's our balance initially? Well, our balance is going to be the deposit. All right, so once we have that, now what do we want to change over time? Well, we want to change the variable balance. So what I'm going to do now is I'm going to indicate, hey, I want to change this variable balance over time. So the problem is, though, balance is in a non-local frame, so I have to make sure I tell the interpreter this is a non-local statement that non-local variable that I'm going to be changing. And then so now I have to check if the amount is, of course, greater than the balance first. If the amount is greater than balance, then I know I don't have sufficient funds, basically. Okay, and then then what I can do now is I can modify the balance. So the balance is always going to be minus the amount, whatever I withdrew, and then I return the balance. So this statement right here would not be possible without this statement. So these two go hand in hand. Anytime you want to do assignment of variables that are not in the local frame, you have to do a non-local statement. So let's make sure that we understand how this works. All right. So withdraw is going to be make balance on 100. And then we're going to withdraw 25. So this should give us 75. And if we withdraw 25 again, we get 50. And then if we withdraw, let's say 30, we get 20. If I try to withdraw 30 again, I get insufficient funds. So here, notice that as we call these functions, it's making a difference to the balance. So this balance is a representation of how much money we have left. So this is how we model like this real-life system that changes over time. We have a non-local variable that changes over time. So this is why non-local statements are so important. All right. So what a non-local statement at the end of the day, through all of its jargon and stuff, it just basically allows for modification of names that are outside of our local frame. So this balance is outside of our local frame, so we want to change it. Hey, I just need to have like an indicator that I want to change this variable. All right. So what we've seen so far is this is a way to model a system that can be changing. So this is the first example of that we've seen. But now I'm going to propose an even better way to do this. And that's going to be using classes. And classes are part of this huge idea in computer science, basically called object-oriented programming. And object-oriented programming is what software engineers throughout the world worship. If there's one thing you want to learn to be a software engineer, it's got to be object-oriented programming, because this is how you represent real-life systems out there in the world. And really, there's no programmer out there who can call themselves a software engineer and say they don't know object-oriented programming. So it's this important, basically. So let's go through classes. This is gonna be. I will warn you ahead of time that I'm going to be introducing a lot of new syntax, because in a way, object-oriented programming is like a different language within a programming language, because it's just a different idea. It's different from the functional programming that we've seen so far. So, and it can be a little confusing. So just fair warning ahead, but I will try to give as many examples as I can to make sure that we understand the basic idea of object-oriented programming. And I'm actually going to spend another video also going through some object-oriented programming examples, because I think it's that important. It deserves 2 videos. But anyway, I'm going to basically introduce the idea here. So classes are essentially a blueprint for representing large ideas. So if I have, like for example, if I have the example I'm going to use in this video is a car. A car can't be just represented as a function, because a car can do many different things. It can drive, it can fill gas, it has a color, it has this. How do you represent all this in a function? It doesn't make any sense. So basically what classes do is they allow a blueprint for this type of large idea. So like if you have a bank account, also a class is a good way to represent that. If you have a grade book or like a general system that changes over time, a class is a great way to handle this. And then at the end of the day, classes are used to create these things called objects. And objects are particular versions of a class that can perform various tasks. And the specific vocabulary for it is that the object is an instance of a class. So just that's something to know. So because I said we would be talking about cars, let's start with a very broad question. How would we model a car if we had to model in terms of programming? Well, there are some inherent properties that cars have. A car has a model and a color, and it also has a particular number of wheels. And it turns out that every single car in the world has 4 wheels, so that's something interesting to keep in mind. But then also it's important to understand that specific cars have specific characteristics. Like for one example, one car might have a 20-gallon gas tank, while another car might have a 30-gallon gas tank. I don't know. So these are different things that could vary among cars. So this is a little complicated because there's some things that are shared among all cars, and there are some characteristics that are specific to particular cars. So taking these two ideas together, it actually happens that object-oriented programming is a great way to express these two different ideas in terms of properties of something. Now, another thing object-oriented programming is very good at is it can also express a very important aspect of a car, what it can do. A car can drive, of course, and a car can also fill its gas. So for now, this is all I'm going to focus on for this lecture or video because I want to slowly introduce this concept of object-oriented programming because it can be confusing, as I said. But I'm just going to go straight into designing a car in program, as a program. So let's take a look. Alright, so I have defined down here, let me bring it up, a class car. Okay, so this is my grand car right now. Oops. Okay, so I'm going to define a class car. So this is a class statement, and we basically have, this is going to be our blueprint for this entire thing. So, what does a car have? Well, every single car out there has a number of wheels. Okay, how many number of wheels does it have? That's 4. Okay, so that's pretty straightforward. Now, why I defined it as such, I will talk about later. But one thing really, really important in object-oriented programming is we had to find a way to build a car, right? We had to find a way to construct a car. So how do we do that? Well, there's actually this idea called a constructor. So what this constructor does is it basically makes specific types of cars. So if I want to make a Tesla, I would use a constructor to make a Tesla. If I want to make a Mercedes, I would use a constructor to make a Mercedes. So, but basically what the constructor should do is should give it some initial like characteristics. We care about the characteristics of the car. So here, what I'm going to do is I'm going to define a constructor. And the way we do that is we use a define statement, but it's actually a little different. And we do this special syntax. So again, there's going to be a lot of special syntax that's involved. So I don't want you to get too bogged down by that. I'll explain how they work. So we have this, it's called an init statement, or broadly it's called a constructor. And we always have this first argument in object-oriented programming called the self. And what the self does is it's a reference to the car itself. Like the car should have an idea of itself. It's a little confusing, but you'll see how this can be very useful. So the car has itself, and then it also has, let's say we want a car to have a model and a color. Okay? And so now, because we have a reference to itself, we can give this car attributes. Okay, so each car is going to have a specific model, and each car is also going to have a specific color. And it happens to be that we're just going to bind these initially to whatever we pass in. So we're going to pass in. So this is kind of like a function, but a little different. You'll see it later. But we're going to pass in things, and we're going to bind them to our attributes. So these are going to be what I've defined here, right, is called a class attribute. And what I've defined here is an instance attribute. Now I can make separate instance attributes too. So if I want to make what's something each car has uniquely, it has a notion of how much gas it has left. So the gas initially is going to be 20. 20 is going to be our representation of a full tank. All right. So already here, I have a very, very basic version of a class. So let's see what it does. I'm just going to interactively do this. So now, well, what's the use of a class? So again, the use of a class is to build objects. And objects are specific instances of a class. So, for example, one specific car I could have is a Tesla. Happens to be my favorite car. But anyway, so Tesla is a car. Okay, and so what I'm going to do, this notation I'm going to show you next, is basically calling its constructor, essentially. And so one thing we don't do in object-oriented programming, it's kind of weird because, actually, let me just show you how this works. So we have a model, Tesla, and we have a color. So what's color? I'll say black. And then this works. So then you might be wondering, hey, this has 2 arguments, but this has 3 arguments. How does that work? So great question. Now, the reason that whenever we call a constructor that we only pass in 2 arguments instead of 3 in this case is because self stands alone. Self is a reference to the object that we just made it. So implicitly, this is kind of crazy actually, but take a moment to wrap your head around this. Self is actually bound to Tesla. And so we'll see how this works. So because self is bound to Tesla, every instance of self has now an attribute. So now we can get Tesla.model. And why can we get this? Because self is bound to Tesla. So Tesla.model is Tesla, and Tesla.color is black. So, and then also Tesla has an idea of how much gas it has. So it has 20 gallons of gas right now. And then also, Tesla also knows how many wheels it has. So these are all things we can do with this very simple blueprint right now.